You wait on a sun-warmed you wait on a sun-warmed rock perfectly still, facing into open air. You are not resting, you are calculating. You have been calculating since the moment you landed, your enormous compound eyes scanning a hemisphere of airspace that no other insect in this field can see as completely as you. Something moves. A fly, a bee, a dragonfly 3 times your size. It doesn't matter what it is. What matters is the gap between you and it, the angle, the speed, the fraction of a second you have to close that distance before the target registers danger and changes course. You launch. For millions of years, robber flies have been doing exactly this. Not waiting at flowers, not building colonies, not scavenging from the ground. Hunting live prey in open air, one of the most difficult and dangerous feeding strategies any insect has ever evolved, and mastering it so completely that researchers who study predatory insects consistently rank them among the most effective aerial hunters on Earth. Cornell University has documented the robber fly family Acylidae as one of the largest predatory insect groups in the world, containing over 7,000 described species found on every continent except Antarctica. The Smithsonian Institution holds extensive collections tracing robber fly evolution across tens of millions of years, with fossil records suggesting the basic design of this insect has remained remarkably stable across that entire span of time. That stability tells you something important. When a hunting strategy works this well, evolution rarely needs to improve it. You are a robber fly, and almost everything about your body was built for one purpose: the strike. Your eyes are the first thing most people notice about you. Two enormous compound eyes that bulge from the sides of your head and meet in the middle, forming a continuous visual field that covers nearly 360 degrees. No blind spot, no safe approach angle. Anything that moves within your range of vision is already being tracked. Entomologists at the Entomological Society of America have studied robber fly visual acuity extensively, documenting how the forward-facing acute zone of your compound eye provides a resolution of detail far higher than most insects achieve, allowing you to detect, identify, and track fast-moving prey at distances that would be invisible to a housefly looking at the same sky. Between your eyes sits a depression, a small hollow in the top of your head, known as the vertex, that gives you an unobstructed upward view while you scan from a perch. You watch what flies above you. You judge size, speed, and trajectory before you commit to a launch. Your body bristles with stiff hairs and spines, not for decoration, but for grip. When you seize prey mid-flight, those legs clamp together with a force disproportionate to your size, and those spines prevent even the strongest target from pulling free until you have finished with it. At the center of your face sits your weapon, the proboscis, a rigid dagger-like mouth part reinforced internally to withstand the pressure of plunging into the body of a live, struggling insect, while you and your prey are both still moving through the air. It does not simply pierce, it injects. The venom you deliver is a mixture of neurotoxins and proteolytic enzymes. Neurotoxins that paralyze the prey within seconds. Proteolytic enzymes that begin breaking down muscle and organ tissue from the inside, a process called extraoral digestion, meaning digestion that happens outside your own body, inside the prey. The Royal Entomological Society has published detailed analyses of robber fly's saliva composition, describing it as one of the most sophisticated venom cocktails in the insect world, precisely engineered to simultaneously immobilize prey and begin liquefying its internal contents while you feed. You do not chew, you dissolve and drink. Within minutes of a successful strike, the internal structure of your prey is becoming liquid. You pump it out through your proboscis, a slow withdrawal of everything the other insect spent its entire life accumulating, consumed in the air, sometimes while both you and the prey are still moving, the dead insect hanging from your grip like a shell. Is that disturbing? Consider what it required to arrive at this method. Aerial interception at high speed, instantaneous grip strong enough to hold a struggling bee, venom fast enough to end resistance before the prey can injure you, and a feeding system that works without requiring you to land, to find a surface, or to slow down long enough to be caught by something hunting you. Let's reconstruct a single hunt in full, because the details reveal just how extraordinary your capabilities actually are. You sit on a fence post at the edge of a meadow. The morning air is still, your body temperature is rising with the sun, and your reaction time is sharpening accordingly. Robber flies are ectothermic, meaning your body heat comes from your environment rather than internally, and your hunting performance is directly tied to ambient temperature. On cold mornings, you are slower. On warm afternoons, you are at your peak. The University of Exeter has documented how robber fly attack success rates vary significantly with temperature, peaking during the warmest parts of the day and dropping sharply when temperatures fall below the optimal range for both your muscle function and your visual processing speed. A hoverfly enters your visual field, moving laterally, approximately 40 centimeters away. Your brain calculates the interception point without conscious decision, not where the hoverfly is now, where it will be when you arrive. This predictive targeting, the ability to launch toward a point in space where prey will be rather than where it currently is something researchers have studied in only a handful of predatory animals. And robber flies demonstrate it with a consistency that places them alongside birds of prey and jumping spiders in the literature. You launch from the post, wings beating in a tight, controlled burst, body angling toward the calculated interception point. The entire flight from launch to contact takes under half a second. The hoverfly has no warning. Robber flies approach from behind or below, minimizing the visual disruption to the prey's own field of view, and your flight path during approach is remarkably silent. No buzzing approach angle, no dramatic shadow. You simply appear from the precise direction the prey is least likely to detect. Contact. Your legs snap around the hoverfly's body before it processes the impact. The spines lock. The proboscis drives in. The hoverfly will be dead within seconds. You carry it back to your perch, or in some cases begin feeding immediately in the air, returning to a surface when the struggle fully stops. This is the counterintuitive twist that most people miss when they learn about robber flies. The impression this insect creates is one of violence and aggression. The reality is something closer to engineering. Every element of the hunt was solved. The approach angle, the grip mechanism, the venom chemistry, the feeding method to minimize risk to you, maximize reliability of capture, and extract the maximum nutritional value from each target with the minimum time spent exposed. Nature has published research comparing predatory efficiency across insect hunters, placing robber fly strike success rates somewhere between 60 and 90% across species studied, a range that exceeds the hunting success rates of most vertebrate predators, including some of the most celebrated large carnivores. 60 to 90% on flying targets, in open air, at speeds that make the entire encounter invisible to the human eye. What you target is also remarkable. Robber flies do not discriminate based on prey size the way most predators do. Smaller species take smaller prey, but larger robber fly species, some of which reach body lengths of 5 to 6 centimeters, regularly attack prey significantly larger than themselves. Bumblebees, dragonflies, other robber flies. Tarantula hawk wasps, one of the most venomous insects in North America, have been documented as prey of large robber fly species, despite carrying a sting capable of incapacitating vertebrates. The University of Florida has documented multiple large robber fly species successfully subduing tarantula hawks, suggesting that the speed of the strike combined with the immobilizing venom can overcome the defensive capabilities of insects whose sting would otherwise make them almost untouchable. You are not the largest predatory insect in a given meadow, but in terms of prey taken relative to body size and the degree of difficulty of capture, you may be the most efficient. Your life before the hunts you are now famous for was not glamorous. You began as a larva in the soil, feeding on decaying organic matter, the eggs of other insects, or the larvae of beetles and flies hidden in rotting wood and leaf litter. The larval stage lasts anywhere from 1 to 3 years depending on species and environmental conditions. A long, invisible development underground that nobody studies in the same way the aerial adult life attracts attention. That hidden beginning is part of what makes robber flies ecologically important in ways beyond the hunt itself. In the soil, your larvae are participating in nutrient cycling, suppressing populations of wood-boring beetles and other insects that would otherwise cause damage to forest and agricultural environments. The adult that eventually emerges and hunts with such precision spent years shaping the soil food web from below, completely unnoticed. The National Geographic Society has described robber flies as keystone predators in many grassland and open woodland habitats, meaning their presence significantly influences the structure of the surrounding insect community, suppressing certain prey populations and maintaining a diversity that would shift measurably if robber flies were removed from the equation. When you finally emerge as an adult, you spend days hardening your exoskeleton and calibrating your flight muscles before your first hunt. Adult robber flies live only a few weeks to a few months, a brief window in which everything accomplished across years of underground development must now be expressed in the air, in the brief violent moments between a perch and a prey item. Mating itself is dangerous. Male robber flies approach females cautiously because a female that does not recognize a mate as a mate will treat him as prey. Some species have evolved elaborate courtship rituals involving hovering displays and gift-giving behavior where a male presents a caught prey item to a female before attempting to mate, essentially offering proof of hunting capability while also occupying her predatory attention with something other than himself. The University of Georgia has documented gift-giving mating behavior in several robberfly species, describing it as one of the more fascinating behavioral adaptations in any insect group, a survival strategy that doubled as a fitness signal, allowing females to evaluate potential mates based on the quality and size of the prey they brought. This is the part of the robberfly story that reflects something most people understand. The most capable hunters do not simply demonstrate their skill to the world, they demonstrate it to the one audience whose judgment actually matters. Does that sound familiar? Many of the most consequential decisions in life involve an audience of one. The presentation that matters is not the one to the crowd, but the one to the person whose opinion determines whether you move forward. The hunt that matters is not the one you perform for yourself, but the one that earns what comes next. After mating, females deposit eggs in soil, bark crevices, or plant material, sometimes in groups, sometimes singly, depending on species. The eggs hatch into larvae that will spend the next year or more underground, invisible, doing the hidden work that makes the adult possible. And then, one warm morning, another adult robber fly will emerge from somewhere in the soil of the same meadow, climb to a sun-warmed surface, let the heat sharpen its eyes, and begin scanning the air above a field that has no idea what's about to happen. You wait on a sun-warmed rock, perfectly still, facing into open air. And somewhere in the sky above you right now, something is flying that does not yet know it has already entered the only part of your visual field that ends in its survival.